look at state trees in 5.5 and look at parameters, how we can get them, set them, and bind them either manually or automatically. So this is Unreal 5.5 preview, and in the plugins, remember to enable your gameplay state tree and the state tree in order to get access. Once you've done that and restarted, we create our first state tree. Let's go to Artificial Intelligence, State Tree. We'll go for State Tree AI Component, be State Tree Tutorial, and we can open that. So once we open our state tree, and if we go to the asset details, this is a state tree AI component. So we have an AI controller class and a context actor class, and by default the context actor is pawn. Here we then get the actor and the AI controller, pawn and AI controller, and they have this context label or category to them. We can create on this side in parameters, we can create global parameters. So these are global parameters on the left, and you can give them names and different types as needed. Just remove that for the time being. So that's the basic appearance. In this particular example, we're just going to take this cat AI enemy and we're going to move him to this move to location actor. So if we just start creating some states, so we'll say add a child state to the root, and we'll say get move to location. And then we can create our first task. So a task blueprint base. We'll just call this state tree task get move to location. We can get the enter state there. Now say for instance we wanted to get access to these variables here, the actor and the AI controller. So in our state tree task, we have access to variables here. We could just put in a variable, say we want the AI controller reference of type AI controller. We compile, and if we put this task here that we've just created, so get move to location, well, first of all, nothing shows up in the variables. So let's expose it. So now it shows up here as an option, and we can bind it. So it gives us the option to bind it to the AI controller. So that would bind it to this AI controller. But what if we wanted this to just happen automatically? Because it's a hassle for every task to have to do the binding. So let's just clear that. What you notice is that this has got a context label to it. So if you go back here, go to your AI controller, and in the category, if you type in context, now compile and go back, and you notice that it has now automatically found the correct AI controller in the context and it has bound it to it. You get this sort of chain icon. Also you notice we've exposed it, but if we unexpose it, whereas previously nothing showed up, but because it's a context here, it will still show up here. So if it's under the category of context, you don't need to expose it as being visible. So that's one. Say we wanted to get, let's just go back, and say we wanted to get a reference to that pawn of ours. So again, we could just say pawn reference. Exactly the same, we could just now give it the correct type of pawn. And if we give it the category of context, We don't need to make it visible, just compile, go back, and again it's automatically been set. So we've managed to set it to these two variables here. Let's say we wanted to just get a random location, so get random reachable point, and we wanted to set this radius. So we could promote this to a variable, call that radius, compile. Again, in this we'd have to expose it to make it visible, otherwise it won't show up. And now we have the radius, so we could set that at 100, and that is a value that would come through here. However, say we wanted to have a fixed radius that we were set up as a global parameter. So if I go there and I put this as a float, and then I just maybe rename this as radius, I could set this to 200. And let me just make this a bit smaller so things show up. If I go to the radius, I can now go to the parameters, global parameter, and I can bind it to the radius. So that would bind directly. However, this is still exposed here. Say for instance we wanted to force the user to actually bind it to a global variable. Well, the other category to be aware of, if you go to radius, is if you put this as input, compile it, now you get this radius with an in label next to it. If you try to compile this, you'll get an error saying that the input property radius is expected to have a binding. So this forces you to bind it to a parameter. So we've got a global parameter called radius here. We could bind it to that. You also notice that on the actual state itself there are parameters here which are only accessible within this state or its child states. So we could have another property here. We could let's rename that. Maybe this is just a local radius. And we could just bind it to that. So there's a global parameter radius, and there is a root get moved to location parameter local radius. But the input, when you put that as an input, and again if it's an input you don't need to expose it to make it visible, it will just automatically show up. This means that the person, whoever is creating this state tree, has to bind it to a value, and that value will often be a parameter that they are setting. Or if it's a child task, they can bind it to the parent parameter. So in our example, we want to get a move location and to send it back to the state tree. And we want our character to move to this BP move location, which I've created. Let's just get rid of this. So we'll just make this easy. We'll say get actor of class BP move to location, and there's only one on the level. I can get the get actor location, and essentially we want to send this value back to the state tree. So how do we do that? Well, first of all, we can just promote it to a variable and say this is the move to location. That will be a vector. We could put it like this, compile it, and it would show up here. But actually the correct way to do it is, because we want this to be an output, we don't want to be setting it here or binding it here, we want to be sending it back. So if we go back to our state tree, and on the move to location, the third category to be aware of is output. And again, if it's an output, you don't actually have to make it visible. It will automatically just show up here, so as an output. And this is now something that another task can bind to. So we've got our output. We could add another task here, move to. Now in state trees, if tasks are so one after the other, or one is a child of a parent, then it will have access to the variables in the state that comes before it. So for instance, here in the move to, there is a destination, so where we want it to move to. I'll just go and make that smaller. We can bind this, so to our previous task, get move to location. We can bind it to that move to location. So to that move to location value that we had set originally in the output here. So this has direct access to it. So we outputted the value and we can bind it in the task that follows after it because they are in sequence. Or if this was a child of this, it would also have access to that. So if we just connect everything up in our task and in our AI controller, if we set our state tree and we just run it, this player should hopefully run into this box here. So he runs precisely into the location of the box. Now there's one thing that you might wonder is, what if this task was not following on from this task and it wasn't a child of the task before? Would it have access to this output location? And the answer is no. So let's just have a look at that. If we get rid of this one that we did, and remember with all of these you can just promote them to parameters. There's the option to promote to parameter either globally or on the actual task itself, this parameter or these parameters. They have access to logic, maths, intervals, and you also get access to the actor location itself directly. But let's just get rid of this. So if I delete this particular task, the problem is if you untick this, it has a habit of crashing, so it's easier just to delete it. And if we create a sibling task here, so a sibling task, and we say move to found location, and on this, if we create the move to, so we get the AI controller, that's automatically bound. But if I go to the destination, I don't get access to this move to location output. So how do we store this somewhere else so that we can get access to it here? I mean, for instance, we could, on this parameter, we could create a global parameter. We could set this as a vector. We could just rename that and say this is the global move to location. But how do we write the result that we are getting here into this parameter there? Because we want this move to task destination here to bind to the global parameter global move to location here. But we have to get the location from this task. So you might think, what if I bind this to this and just write the value to it? Obviously we can't do it as an output. So we go back here maybe we change this to an input, then we set it. In this particular case, we'll have to finish the task because we wanted to move on to the next task. We go back to our state tree. Now it's an input, so we can bind it on the global parameters to the move to location. And on this task here, we'll put a transition, so when it's completed, it will go to the move to the found location. So if this was to work, we would have we've bound it, we've written it to the move to location, which we're assuming will write it back to the global move to location. And then in this task, we've bound the destination there. But if we go and play, well, nothing happens. There is no move to location for the character to move to. And that's because this value is being copied here instead of being sent by reference. So you might think, what if I do a set by reference vector instead of a normal set? Again, it doesn't work. And this was a problem in 5.4. There was no way of setting it, of writing back to what is the global parameter or even one of these parameters, unlike in sort of AI behavior trees and blackboards. However, in 5.5 they brought in a new node, and that is a get property reference node. And with this, we should be able to write back this value into this location here, and then access it in another state, which is not a child state of the state in which we set it. So how does this work? Well, first type a get property reference, then just promote this to a variable. We can rename that and say this is our move to location property reference. It comes as a state tree property reference type. But if you click on the actual variable, compile, you can now set it's a reference to what type of variable, and we want to set it as a vector. Now when we compile, this node, which was a wildcard, is now a vector reference. And now we can say set by reference variable. We can put in the location where we want to move to, and on success we finish the task, and on failure we should say finish task. We'll just say failed. We don't necessarily have to give this a category or even to expose it, I think. Let's see, does it just show up? No, it doesn't show up on its own. If we expose it, compile it, then it shows up, and it shows up as something that needs to be bound. We could actually just give it an input again here, just to make it very clear. Go back. Now it says move to location property, input, vector, and now we just need to bind it. So we can click here, go to our global parameters, and pick global move to location. So now we've got a reference to this which we can set in the state tree. In our move to task, we've bound to that just like we did previously. And if I change these to how we had them, so acceptable radius 1, and get rid of the agent radiuses so it goes in the center, and this should then go there. So let's have a look what happens now. So now he goes directly exactly as he did previously, but this time he's using the global move to location, which we set using the new node that's available in 5.5, this get property reference. And the advantage of this is it allows us to use our parameters like we use blackboards in the AI behavior tree, because we can essentially set this property reference to almost any type that's available in Unreal. And that makes your life a lot more easier. So I think we've looked at basically the main how to get, set and bind variables and parameters in the state tree, and how the importance of using the correct category on your variables is. So if you put context, it will automatically bind to anything which is a context in the asset details. If you put as an input, you'll get an in after it, and that will force you to bind it to a parameter that already exists. And if you use output, it will then send that result back to the state tree, which you can then bind to in another state, which is a child state of the previous one. And last of all, we looked at this get property reference node, which allows you to set the type of the property reference, which can be bound to by a parameter in the state tree, and then to set its value by reference, which allows you to write back to a parameter a value, which you couldn't do in the previous state tree. So putting all this together, that should make controlling your state trees and passing data and setting them a lot more easier, and allow you to create some complex state trees as a result.